Question 11 of part 2 of the homework says that Kepler's third law of planetary motion relates the average distance a of a planet from the Sun to the time t it takes the planet to complete one full orbit around the Sun, according to the equation t squared equals a to the power of 3. When the time t is measured in Earth years, the distance a is measured in astronomical units, and 1 AU, or 1 astronomical unit, is equal to the average distance from Earth to the Sun. So in part A, we're asked to find an equation for t in terms of a and an equation for a in terms of t. So let's start with what we've been given. The equation is t squared equals a to the power of 3. So if we want an equation for t in terms of a, we want t by itself. So to do that, we take the square root of both sides of our equation. This cancels out and we're left with t. And on this side, we can rewrite this as a to the power of 3 over 2. So we're putting it to the power of 3 and taking the square root. We can do this again for writing a in terms of t. And so in this case, we want to get a by itself. So we take the cubed root of both sides of the equation. Sorry, that's a bit messy. On this side, it simplifies to just a. And here we have t squared and the cubed root, so that's, we can rewrite as t to the power of 2 over 3. Okay, because we're squaring it and taking the cubed root. So those are our equations for part A. In part B, we're told that Venus takes about 0.616 Earth years to orbit the Sun. What is the average distance from the Sun? So we're trying to find the average distance in this part of the question, which is a. So we're going to use this equation. So we have a equals t to the power of 2 over 3. And we can just plug in what we've been given. We've been told that t, the time it takes a planet to complete one full orbit, is 0.616 Earth years. So this is going to be 0.616. We're putting it to the power of 2 over 3. So evaluating this out, we can rewrite this as the cubed root of 0.616, and that squared, right? Because we're taking the cubed root and squaring it based on this fraction exponent. It's important to note that we could do this the other way around. We could take 0.616 square it first and then take the cubed root, and it'll give us the same answer. So you can try that out, convince yourself of that, but either way is fine. And plugging this into your calculator, you get a long decimal, so I'm just going to round and say a is about equal to, doing this inside first, the cubed root of 0.616, 0.8509. And we have to square that. So when we square it, we get a is about equal to 0.724. And our units for that is a is in astronomical units. So we can say that the average distance from Venus to the Sun is 0.724 AU, or astronomical units. Okay, so that's the answer to part B. Part C, we're told that Mercury is an average distance of 0.387 AU from the Sun. About how long is its orbit in Earth years? So in this case, we want to use this equation because we're trying to find t, the length of its orbit. And so we have t equals a to the power of 3 over 2. Plugging in what we've been told that the average distance is 0.387 AU. And it's to the power of 3 over 2. So again, you can do this in either order you want. I'm going to take the square root of 0.387 and cube it. When I do that, again, get a decimal, so I'm going to round. It's about 0.622 is the square root of this number. I'm going to square that, or sorry, cube that. And that gives me t is about equal to 0.241. And the units of this are in Earth years, so the orbit is about 0.241 Earth years. Okay, so those are the answers to question 11 of part 2.